Hello everyone, welcome back to the lecture on design of reinforced concrete structures. I am Jyothirmai, Assistant Professor, Department of Civil Engineering, Vienna, VJEC. Have you ever seen steel bars tied in a beam or a column and wondered how engineers decide their exact placement? That process is called reinforcement detailing, which is topic of today. In this video, we will understand how reinforcement is arranged in various structural members and why proper detailing is crucial for strength and safety. The precise placement and arrangement of steel bars within concrete ensures structural integrity. This process bridges the gap between theoretical design and actual site execution. Firstly, I would like to show you scaffolding and formwork, which is the most crucial part of any structural element, either beam, column, slab or footing. This picture shows, figure number 1 shows you the part of scaffolding which will hold man and materials that transferred from one floor level to the other floor level. And this can be made of timber, aluminium and steel, which are the commonly used materials to make scaffolding. And the second picture shows us the formwork, which is laid to cast slabs, beams and columns. And this will be supported using truss elements made of steel to make sure it can carry the weight of wet concrete safely. These two elements can be commonly seen as a part of any construction. And you can also see scaffolding providing support to the slabs in the form of props. Moving on to the next one, which is slab reinforcement layout. In slabs, we'll have two major types. One is one-way slab, where the ratio of Ly by Lx is greater than 2. And the other one is two-way slab, where Ly by Lx would be less than 2. So Ly and Lx are the spans in longitudinal and lateral directions. In slab, we provide reinforcement in both the directions. In one-way slab, we provide main reinforcement in one direction and secondary or distribution reinforcement in the other direction. These two reinforcements are to be provided in the form of layers, as you can see in figure number 3. Similarly, for two-way slabs, the reinforcement is provided in both the directions and both of them are main reinforcement. Each of these reinforcements will be of different diameters and they should be laid in layers. How can they be laid in layers? I would like to show you figure number 4, which is cover block or spacer block. This block will make sure that there is proper concrete cover to protect the reinforcement. And figure number 5 is chair car. In order to provide reinforcement in layers, we make sure that the chair car is provided between the layers. This will also ensure that these bars does not undergo bending due to weight of the materials or due to movement of humans on the slab before concreting. And I would also like to show you one more important video in the figure number 3, which is pumping of concrete. Once the reinforcement is laid for the slabs, this is how pumping is done to pour concrete into the spaces of the slab. This will ensure that the reinforcement is completely covered with concrete, which becomes your reinforced concrete slab. Moving on to the next and important reinforcement detailing, which is a beam column joint. The detailing near beam column joint is to be taken utmost care because the main reinforcement of the bars of the beam and the main reinforcement of the column comes in contact at the same time along with the slab reinforcement. As you can see in the picture, I would like to show you the couplers. Mechanical couplers are provided for the columns for high-rise structures when we do not have enough length of the bar. So this will allow to ensure that the column is constructed for enough height. These points, which I have highlighted in figure number 6, represents the mechanical coupler joints. And you can also see the bent up bars in the slabs in this picture. All of them come near beam column joint. And in more particular, I would like to show you the zoom in view of the rebar congestion near the beam column joint. As you can see in this picture, there are various diameters of the beam and various diameters of the column and diameters of the slab coming into contact here. As you can see, all of them are tied using binding wires in the picture. We should be able to provide space for this one. We should be able to provide enough space for main reinforcement in the column. We should be able to provide enough space for lateral ties in the column. Similarly, we should provide space for stirrups in the beam and main reinforcement in the beam. Stirrups will ensure that the beam is safe against shear, and main reinforcement in the beam will ensure that the beam is safe against bending. Coming to the column, the objective of lateral ties is to make sure that the main reinforcement of the columns are held in position and also to confine concrete in position. And these bars can be of different diameters as per provision of the IS 456. And you can see here, the next one that I would like to tell in detail is about the column reinforcement. The lateral reinforcement that you're providing in the column is not just one or two layers, as you can see in this picture. There are a number of lateral ties coming into one column, which is trying to hold the different diameters of the column in position. So we need to understand that it is not single lateral tie which will be sufficient to make sure that the entire longitudinal reinforcement of the column will be holded. Here also, you should observe that we need to provide enough space for the electrical conduit systems so that electricity is provided to the entire building. All these are to be taken care while we are giving any kind of reinforcement detailing. And in particular, I would like to show you the column reinforcement. This is a longitudinal reinforcement in the column, and this will become the lateral reinforcement in the column. The one shown in the picture is a rectangular column which is in the second floor. And the next and most important one is the reinforcement in the footing. As you can see in this picture, the reinforcement is provided in the form of cage, and the reinforcement in footing will be provided in the substructure part so that it should also take care of the load coming from the soil. And this footing reinforcement is very, very important to make sure that the structure is safe. The column reinforcement gets embedded into the footing reinforcement, and that's how the column reinforcement is above the superstructure. And this video will show us how the bars are bent in the footing and also how binding wires plays important role to make sure that the bars are kept in enough spacing from one layer to the other layer. This video will show us how the reinforcement in footing looks like and also how the column reinforcement is embedded into the footing before the beginning of the construction. So this video has shown us all the different detailings of beams, columns, slabs and footings, and how longitudinal bars or how lateral reinforcement is provided in various structural elements. This detailing plays a really very important role to make sure that the structure is very safe against any kind of loading. The detailing is the most important part in any construction. It has to be done with utmost care, because even if one diameter of the bar or spacing is not done properly, it might lead to failure. So, this detailing, I hope, will help you to learn further how the different structural elements are designed in reinforced concrete structures. Let us all meet in the next video. Thank you, everyone.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.